Intro. What we're really doing. Prompt engineering is not magic. You're not tricking the model. You're doing something much more boring and much more powerful. You're telling the model exactly what you want, giving it the right context, and putting hard boundaries around what it's allowed to say. That's it. Clear instructions plus context constraints equals good AI. What is prompt engineering? Prompt engineering is simply how you talk to the model so it gives you correct, safe, predictable answers. Think of the model as a very smart but very literal trainee receptionist. If you give vague instructions, it will guess. If you give clear rules, examples, and boundaries, it behaves like a pro. That's prompt engineering. What is a hallucination? A hallucination happens when the model guesses instead of using facts. Imagine your koala dental agent. User, how much does a root canal cost? Model, it costs $50. Confident, polite, totally wrong. That's a hallucination. It usually happens when the prompt is unclear, the model has no context, RAG isn't used, temperature is too high. Your job is simple. Reduce guessing. Maximize grounding. Core prompt patterns you must know. The exam expects you to know these patterns and when to use them. 1. Instruction prompting. 2. Role prompting. 3. Few-shot examples. 4. Template structured prompting. 5. Chain of thought. 6. React, reason act. 7. RAG, retrieval augmented generation. 8. Guardrails. Let's walk through them like you're training your own AI receptionist. Instruction prompting. Just tell it what to do. Instruction prompting is the simplest pattern. You tell the model exactly what to do, clearly and explicitly. Bad prompt, write a greeting. The model can say anything. It has no constraints. Good prompt, write a short, polite greeting for Koala Dental in Sydney. Keep it under 20 words, no emojis. Now the model knows who it's talking for, tone, length, and style. The exam loves this. Clear instructions reduce hallucinations. Role prompting. Give it a job title. Next, we give the model a role. Instead of a blank voice in the sky, we say, "You are Emily, an AI receptionist for Koala Dental. Your job is to answer patient questions clearly, politely, and concisely." Roles control. Tone, level of detail, safety behavior. A model speaking as Emily the receptionist will behave differently than a marketing copywriter or a stand-up comedian. For the exam, remember, role equals behavior tone control. Few-shot prompting. Show, don't just tell. Few-shot prompting means don't just tell the model what you want. Show it examples. Example, here are some examples of how you should answer. Example 1, user, what are your hours? Assistant Koala Dental is open Monday to Saturday, 8:30 a.m. to 5 p.m. Example 2, user, do you take emergencies? Yes, Koala Dental accepts emergency patients. Please call 02-9999-NO. Now answer this. User, how much is a checkup? By showing patterns, you train the model inside the prompt. This reduces hallucination and makes answers consistent. Exam takeaway. Few-shot equals pattern teaching plus consistency. Template structured prompting, always in this format. Now we tighten things even more. We define a response structure. For example, answer in this format, short answer, additional details, safety note, if needed. Now you can reliably parse the model's output in your code or agent. No surprises. The exam will connect this to tools and agents, JSON outputs, workflow automation. Structured prompting makes the LLM predictable. Chain of thought. Think out loud. Chain of thought is asking the model to reason step by step. For example, why does a root canal usually cost more than a filling? Explain the reasoning step by step. Make each step short. The model might respond, root canal takes more time than a filling. 2. Requires specialized equipment. 3. Often needs multiple visits. 4. Saves a severely damaged tooth. 5. Dentist needs extra training. This reveals the reasoning, not just the answer. Good for math, logic, planning, explanation. Exam note. COT needs better reasoning, but more tokens and latency. React. Reason plus act for agents. React is the pattern used in tool using agents. The model, 1. Thinks about the user's request. 2. Chooses an action. 3. Calls a tool. 4. Uses the tool result to answer example in your dental agent. User, do you have any availability tomorrow? The model reasons. User is asking about appointments. I should call the check availability tool. After the tool returns slots, the model writes the final answer. For the exam, remember, React equals reasoning plus tool calls. Retrieval augmented generation. RAG is the king of hallucination control. Simple definition: the model looks up facts in your documents before answering. Dental example: patient, how much is a molar root canal? Your system: 1. Turns the question into an embedding. 2. Searches your vector database. 3. Finds the chunk with root canal pricing. 4. Inserts that chunk into the prompt. 5. Asks the model to answer using only that context. Now the model isn't guessing, it's reading your price list. Exam mindset: for accuracy questions and domain knowledge, RAG, raw prompting. Guardrails, safety bumpers. Guardrails are the safety rails around the LLM. They define what the model is not allowed to do. For example, your dental receptionist should not give medical treatment advice, diagnose conditions, contradict clinic policy, talk about sensitive topics. So your instruction might say, if the user asks for medical advice, respond with, "I'm not qualified to give medical advice. Please contact your dentist or doctor." Guardrails reduce legal risk, policy violations, dangerous hallucinations. Exam angle: guardrails, RAG, low temperature, production safe systems. Now, hallucination control, full toolbox. Now let's bundle the whole hallucination story together. To reduce hallucinations, you use low temperature, 1.2 for dental, medical, legal, insurance. RAG context. Retrieve relevant chunks and feed them into the prompt. Clear system and user instructions. Do not guess. If the answer is not in the context, say "I don't know." Guardrails. Explicit rules about what not to answer. Right model, sonnet for accuracy. Haiku only when speed matters more than deep reasoning. That's your hallucination toolkit. Real world, bad prompt versus good prompt. Bad prompt: write a dental FAQ. The model invents prices, policies, random opening hours, looks confident, totally fake. Good prompt with RAG, using only the context provided below, answer the patient's question. If the answer is not in the context, say "I don't know." Context: insert retrieved chunk here. Question: how much is a molar extraction? Now the model is forced to stay inside your documents. No context equals no answer. That's how you build trustworthy agents. Mnemonics: how to remember all this for the exam. Let's compress everything into a few memory hooks. Prompt patterns mnemonic. IRFSCRG, I really feel super calm running real guardrails. I equals instruction, R equal role, F equal few shot, S equals structure, C chain of thought, R equals react, ARC RAG, G's guardrails. Hallucination control mnemonic, open quote, low temp, more facts, less freedom, close quote. Low temperature, more facts equals RAG context, less freedom equals strict instructions, guardrails. Right model equals sonnet over haiku for accuracy. If you remember those 2 lines, you'll recognize almost every exam trick around prompts and hallucinations. Final wrap. Prompt engineering is how you talk to the model. RAG is how you feed it real knowledge. Guardrails are how you keep it out of trouble. Temperature and structure are how you shape its behavior.